to talk about what's called inverse variation and joint variation. You guys have actually seen variation before, but you saw it in terms of what's called direct variation. You saw this when you guys first learned about a little something called slope. You guys did stuff in algebra where you had an equation that looked like this, direct variation. Direct variation is y equals k, which stands for some constant, times x. When you first learned about slopes, you would go into like a table form, and you were trying to figure out what was that multiple to x to generate the y value that was constant. For example, you looked at something like this. You had a very simple table of x's and y's. Let's say you had a table of 3, 4, and 5, and your y values were 6, 8, and 10. When you looked at something like that, you were trying to figure out what was that constant. What was the same thing you're multiplying your x's by each time to get you your y's? 2. Are you right with that? Yeah. So when you first learned about slopes, usually this is kind of the scenario that they would set you up with. You'd wind up with the equation, well, y equals 2x. That value of 2 was called that constant. Right? The day after you did those, they called it slope. And then they added in y-intercepts and went from there. Do you vaguely remember that? Yeah. Well, what we're doing here today is something called inverse variation. If direct variation was multiplying, what would be inverse? Dividing. So now you have this constant is now divided by x. So your inverse variation is y equals k divided by x. That value of k just cannot equal 0. If it equaled 0, then you have y equals 0, which is a constant. You have to have some variance here. All right? Yes, sir?
What happens when x equals 0? That
You-
doesn't work, right?
It doesn't work at all yet, because you can't divide by 0. So what this is actually allowing us to be able to do is we're eventually getting into be able to graph these things high.
There are 2 packets.
2 of them, I can't count that high. Joking.
Good, good. Otherwise, that would not be reassuring.
Go away, Grace.
Not be reassuring for us to
Go
learn
make
from
it
men.
Well, what we do. So when we're looking at inverse variation, it looks just a little bit differently. And I'll show you guys some table stuff here in a minute. What they say is, when you read it, they'll say a couple of different ways. Y varies inversely with x, or it'll say x and y vary inversely. A little bit. The lingo here, when you're thinking of x's and y's, it's generally going to be y equals always on these things, because it's y is the f of x, it's the function that's being created. So x and y vary inversely. They mean the same thing as y varies inversely with x. The book says it both ways, and that just means the following. Y equals something divided by x. That's all that means. Now, in order to tell whether or not something is going to be direct or inversely related, it's a matter of looking at tables and trying to figure out what that value of k is going to wind up equaling. If it equals the same thing for each set of the tables, that's how it goes. And I'll show you that. Oh, sorry. Let's do this first. I want to tell whether or not something is inverse or direct when I give you an equation. So if I want to tell something's going to be either inversely varied inversely, or varied directly, if I look at the equation y divided by 5 equals x, what do I have to do to that to tell? What am I going to do, Spencer?
Multiply both sides.
Very good. If I multiply both sides by 5, I get y equals 5x, and is that direct or inverse?
Direct.
Direct. Your value of k is 5. So this is direct. Pretty easy, isn't it? What about the second one? Nothing, because you got that tacked on with the +2. There's no room for addition in these. You got me mid-sick. Yes. Then the last one here, I have x times y is 4. What do you do?
Inverse. No, divided by.
Divided by x, you get y is 4 over x, and that's inversely, right? Let me ask you this. What happens if it's y equals x over 3?
Direct.
Why?
Because when you multiply each side by 3, and then turn it back over, it's direct. No.
It's either.
Is it neither? Is it inverse or is it direct?
Neither. It's inverse direct.
Direct inverse.
Let's see if the book is
Inversely direct.
Guys, inverse means you're dividing by x. Are you dividing by x here?
No.
No.
No. Isn't it the same thing as saying 1/3 times x?
Yeah.
So it's direct.
Correct.
Oh, so I was right.
Yeah, but you couldn't explain it.
Yeah, but I said direct, so.
Wait, how much that? 1/3 x. Oh, that's.
Dividing by 3 is the same thing as multiplying by 1/3.
What's direct? Why is this?
Y equals k times x. K is 1/3. That's all.
Wait, what's
Neither. Because you have this adding into 2. So let's see. Okay. So let me show you what it looks like then via a table. Now, sometimes you're going to get information in table form, and they're going to give you different variables. In this case, they're saying W and H. Well, here's the general idea. That first row, X's. The second row, Y's. If you go with that each time, you're going to be fine. Okay? Same thing with if the tables themselves were written vertically. The first one you read is X, the second one you read is Y. So if you want to play that game, just relabel it as X's and Y's. And if you want to check to see whether or not something winds up being direct or inverse, all you do is you write out the generic formula for both. So it's Y. And what you're going to do is you're going to check a couple. Give me a second while you guys are writing that up. If they wind up being direct, that means that value of k is always going to be the same for each set of ordered pairs. If they're going to be inverse, the value of k would be the same for all of those sets of ordered pairs. So all you're doing is you're checking. For example, I start with the first one. Is 9 equal to 2 times k? Is 4.5 equal to 4 times k? Is 3 equal to 6 times k? I just check those first three. Yes, ma'am?
Wait, is this supposed to be K over X?
Oh, thank you. Thank you. I didn't. Sorry, I didn't realize I did that. I did that the other day, earlier today too. I didn't even realize I did it. Sorry.
It's your first time
Yeah.
teaching it. It'll be 2X.
I'm trying to check to see if k. I'm looking for k.
2 is X.
I'm checking for k because I know my x's and
You
y's.
just put X first. It's official.
That's all. And it's just custom to put the number for the variable. That's all I'm doing. Does that make sense?
Yeah.
So I'm not going to write them out for all of them because you don't really need to. Because if you start to look at it, 9 divided by 2 is what? 4.5? 4.5 divided by 4 is something I don't care, but I know that 3 divided by 6 is a half. These two are not the same, are they? So I know it's not direct. Okay? I don't have to check them all. I check ones I can do real quick in my head. If I solve for k here, I get 4.5 and a half. Those aren't the same. So I know it's not direct.
Oh, they all be the same.
Yeah, that value of k is the same for each one of them then. So when you go to the other one, you'll see this real quick. Does 9 equals k divided by 2? Does 4.5 equal k divided by 4? Does 3 equal k divided by 6. If I check those three to solve for k, what do you get each time? 18. So do you see how if I multiply up by 2, I get k is 18 here, I get 18 here, and I get 18 here. So that means my value of k is 18. Yes, sir?
So when it's like direct, you only have to check two when it's like two don't work. When it's two work, do they all work?
You check the other ones out real quick. But with some of the patterns, you'll see it real fast. So this is not indirect, it's inverse. And people say it all the time. So this is an inverse variation where your k value is 18. So the equation would be y equals 18 over x. All right? Yes, sir?
So, do they make different lines? Does like one make this line? Because we're talking about slope here, right?
Well, direct variation is slope. Inverse relation is not. Inverse relation is different. And we're going to eventually get to what that looks like. You could. It could. All right. Another one. Now, don't write all this out. Let's just walk through it together. That way we can show a couple more here. When I get into this, if I'm going to check y equals k times x, or y equals k divided by x. I didn't write that time, right?
Yeah.
So does 30 equal 10 times k? Does 15 equal 20 times k?
No.
I know right away that doesn't work. Those are easy numbers to look at in your head. The first k value is 3, the other one is not 3. You okay with that?
Yeah.
All right. If I go the other way to check the inverse again, does 30 equal k over 10? Does 15 equal k over 20? Does 10 equal k over 30? What do you get for k? You get 300 each time. So that means my constant here is 300, and my equation would be that's what you're looking at being able to do. Not bad, is it? All right. Now, not only can you do it via a table, but sometimes you have to write it out in terms of an equation.
So first we look to see if they all divide
You
to
didn't
the
need
same
that.
number, and
I was
then
just trying to show you how it works.
we check to see if they all multiply to the same number.
I'm sorry, I didn't hear all that. What?
So at first we check if they all divide and like we get the same number, and then we check if they multiply and we get the same number. Okay.
That's all it is. That's really all it is. Now, what will happen then, after you go through some table stuff, you'll start looking at these. And this should look familiar if you remembered from direct variation with slopes. Because this is the same wording, just instead of inversely, it's direct. So if it says the variables x and y vary inversely when y is 8 and x is 3, that means it's an inverse variation, and you're working with the equation y equals k over x. We're out with that. Now, if they're telling you what x and y are, what would I do to that equation? You substitute in, right? So I say 8 equals k over 3. From that, what could you solve for? What's k? So by giving you two of the first of the three variables, you can solve for the third. Therefore, you can rewrite it as the rule. So if the k value is the rule, your constant, then what would your generic equation look like? So then you would have y equals 24 over x. And g, what do you think you do with part b? Substitute back in. What do you get for y? That's all it is. What's that? Are we okay with? I'm sorry. And I kind of talked through it a little bit fast by 12th hour anyway, because I've done it a couple times. Are we okay with how we set up the generic equation given two variables? Okay. When you use that generic equation that you come up with, once you solve for k, you rewrite it as the rule. This is your rule, y equals 24 over x. Now they're going to ask you, what's y when x is negative 4? So y is going to equal 24 over negative 4. You get it? Negative 6. That's what this is allowing us to be able to do. Okay? All right?
So they're just asking us to find different types of equations.
Yes, ma'am. Do this one. When you start this out, it starts the same way. Y equals k over x. Substitute in what you know. 10 equals k over a half. So did you get k equals to 20?
No.
It's 5. Remember, how do you undo division? Multiply. So how do you undo dividing by a half? You multiply by a half. So what's half of 10? 5. So k is 5.
So is y 5 over 2 or do you want to be 2.5?
Oh, 5 over 2 is fine. That's fine. Hey, Jessica, you're not the only one that got caught on that one today. All right. Not bad? All right, let's talk about varying jointly then. Fractions are a little bit cleaner. I like fractions. Joint variation. Joint variation is a whole lot of words for something that's very, very simple. When you're talking about joint variation, you're talking about joining more than one thing together. And when we're talking about the joining of more than one thing together, we're looking at it in terms of multiplication. So if I want to say something like z varies jointly with x and y, there's still some value of k, but I'm bringing in two variables. I just multiply them together. So what you're looking at here with joint variation is you're using two or more variables together. Let me reword this. So z varies jointly with x and y. So if I want to say that z varies jointly with x and y, all that's saying is that z is going to equal, what are you forgetting?
K.
That's all it is. Z has to equal, all these variations have some constant. It will always have a constant. K times something. That's why. And that's what it looks like. It's a lot of letters. If I want to say z varies jointly with the square of x and inversely with the cube of y.
That's not.
All right, z varies jointly.
Z equals k over x to y cubed.
Z varies jointly with the square of x and inversely with the cube of y. Z varies jointly with the square of x. So z equals what?
Kx.
Go on. Kx.
Squared over y cubed.
That's all it is, guys. All right. That's all that is. Now, writing an equation where you had something like that would be kind of nasty, but it's a lot of substitutions.
If it said z very shortly with the square of x and directly with the cube of y, would it still be z equals kx squared y cubed?
Yeah. If it said, what Katie's question was, if z varies jointly with the square of x and the cube of y, that means it's all direct. It's all going straight across. Okay.
And these ones, are we looking for z or any of the other ones?
I don't know. A little taller. Yes, ma'am.
Wait, so what's the difference between the, like, so what will we get in a problem? Like, I don't get the two equations. So are those two different things? Are they the same thing?
Let me show you. Here's what happens, and this might clear this up for you. Don't write all this down. Don't write, this is all out of your book, guys. All right. Now, don't write this down. Just listen. Y varies directly with X. What is that? Y equals Kx or X times K. We all right with that? All right. Y varies inversely with X.
Y equals
K over X. Z varies jointly with X and Y.
Z equals KXY.
Z is KXY. All right. Y varies inversely with the square of X.
Y equals XK over X.
Whoa!
I have no idea.
Listen again here. Y varies inversely with the square of X.
Oh,
Y equals K over X squared.
Very good. Y equals K over X squared.
20 minutes. I don't care. I'm like,
Z varies directly with Y and inversely with X.
Z equals YK.
YK over X.
Z equals YK over X. Or can you say KY over X? Either one of them is fine. You're not buying it, Ron.
I think we need to just keep going.
You're not buying it.
I think we need to.
Remember, inversely means divide. Directly, multiply. It's in your book. It's verbatim on your book. It's a chart in your book. All right. Because your homework probably will ask you to write out what things will look like, words, and this is right there on that page. Just go back and try and see how it works. No, they're giving you words right at the equation. Just like what I did.
So on the way, like, you want us to write out the word?
No, the equation. Because they're going to give you something like this, you have to come up with the equation. That's it.
He's giving us easy stuff.
Let's do those.
I guess most of them are done.
Mix. Write some equations. It shouldn't be all that scary. It really shouldn't.